So we've already taken a look at rational functions and understood and tried to analyze their asymptotes and domains and things like that. So let's go ahead and apply that knowledge to the graphs of our rational functions in this series of lectures. Let me go ahead and mention that when we are talking about the graph of a rational function, the graph of this rational function will never intersect a vertical asymptote, but it could actually intersect horizontal or oblique asymptotes. So keep that in mind as you graph these both by hand and on your graphing calculator. So let's jump into the very first example we have here, and we're going to walk through a series of steps that I have laid out for you and try to come up with, see if we can graph this function by hand. The first thing I want you to go ahead and do is, when you're looking at this function right here, let's go ahead and look at the domain of this function. The domain of the function is where my function is going to be equal to 0. It's easiest when we set something equal to 0 if it's already factored. So we're going to go ahead and we're going to factor this rational function. So this would look like x minus 1 in the numerator divided by x plus 2 x minus 2. So this is the factored form of my denominator up here. And we're going to take each of these two factors here, set them equal to 0, and solve to find out, well, what number, when I plug it in, gives me back 0 in the denominator. So I have a x minus 2 equals 0 here, and I can see that when x is a negative 2 and a positive 2, those are the values that when I plug it in for x cause the denominator to be 0. That means that I want to throw those two values out, so they are not allowed in my domain. So we're going to say that the domain is going to be x such that x cannot be equal to positive and negative 2. So that's the domain of my function. Once we've found the domain, we want to see if we can reduce this fraction or this function that we have here. Now notice that when I talk about reducing, I can only reduce common factors. I have no common factors occurring anywhere in this function, so I cannot reduce this function. So that's not applicable in this particular case. But we want to move on and we want to talk about the intercepts of this function. The intercepts of this function are going to occur where x is equal to 0, that's going to give me the y-intercept. And again, when y is equal to 0, that gives me the x-intercept. So we're going to solve this equation twice, basically. So for this one over here, this is usually the easiest one. Everywhere there is an x, I'm going to replace it with a 0. So remember that my function was x minus 1, x squared minus 4. So everywhere there is an x, I'm going to replace it with a 0. So this would be y is equal to 0 minus 1 divided by 0 squared minus 4. So 0 minus 1 in the numerator gives me a negative 1. 0 squared minus 4 in the denominator gives me a negative 4, and that tells me that I have y is equal to 1/4. So look, we're going to write the ordered pair. When x is 0, y is 1/4, and we have one of the intercepts of this function. The next one says if I set the function equal to 0 and then solve for x. So remember that my function looks like x minus 1 divided by x squared minus 4 equals 0. And I want to solve for x in this function. To do that, I can either cross multiply, or another way to think of this is multiply both sides by this denominator x minus 4. X squared minus 4, I mean, because that causes the x squared minus 4 to cancel, and this over here, 0 times anything is just 0, so we have x minus 1 equals 0, or x is equal to 1. So now I have another intercept occurring at 1, 0, so this is the x-intercept. And that's how I'm going to go ahead and find the intercepts. The last thing that we want to try to find on this rational function are the asymptotes. And we've already done this before in a previous lecture, but remember that when I'm looking for vertical, horizontal, and or oblique asymptotes. So I'm going to look at the vertical asymptotes first. Vertical asymptotes occur where the denominator of the function is equal to 0. We've solved that already, but we will write it again. The denominator of my function is x squared minus 4, and I can move 4 to the other side, take the square root of both sides, and you can see that we have x is equal to a plus or minus 2. So in other words, I have vertical asymptotes occurring at x equals plus or minus 2. Now how about the horizontal or oblique asymptotes? That's where we want to determine what the degree of the function is and compare the numerators to the denominators. So the degree of the numerator is 1 and the degree of the denominator is 2. So let's go down here and write that down. The degree of the numerator is 1 and the degree of the denominator is 2. And if that is the case, then we have a horizontal asymptote occurring at y is equal to 0. So I have asymptotes I can now put on my graph. I have intercepts I can put on my graph. And we're going to go and start with that piece of information. So we're going to graph this off. I'm going to draw this on my graph. 1, 2, 3. And I'm going to go through here and I'm going to put down the asymptotes and the intercepts. Okay, so on my graph I have labeled a couple of things. I wrote down the two vertical, or I drew on here the two vertical asymptotes occurring at negative and positive 2. I have my horizontal asymptote occurring here at y is equal to 0. And I also plotted my intercepts that I had occurring. So I have this intercept here at 1, 0 and this other intercept occurring at 0, 1/4. After this, I don't really know the shape or where I'm supposed to be drawing my rational function unless I go consult my calculator. So in my calculator, I'm going to enter the function in the y1. Now remember that when we graph a rational function, we want to surround the numerator with a set of parentheses and the denominator with a set of parentheses so that the calculator does the right operations. So here I have my function. I went ahead and zoomed in on this function, so I made my window to be between negative and positive 5 for both the y and the x axes. And then over here you can see I have the picture of the graph. Now what this does for me is it tells me that I have over here in this portion of my graph, I am going to draw something that looks similar to this. That's all I'm really interested in, is some sort of curve over here that is bounded by the x-axis as well as this asymptote here. Then in the middle I have a kind of descending cubic function looking thing that's going to cross through my points that I have labeled. And finally over here in this top right hand corner I'm going to draw something that looks similar to this. So we're letting the calculator kind of do some of our sketching for us, or letting us identify what it is that we are drawing, where we're drawing. And I can come through here and I can connect my graph and then draw it like that. And that's how I would go ahead and draw this function, analyzing this function, and draw this function by hand.